And here we go. So without having access to the application database, we've been able to retrieve all the information within the database. We have the admin email address, and then we have the admin password. Then there's another user's email address, and then the password. Laravel is supposed to protect you from SQL injection out of the box. Eloquent and the query builder handles it for you. Parameters get bound, inputs get escaped, you are safe. So a lot of developers assume SQL injection just isn't the problem anymore. But here's the thing. The moment you step outside the guardrails, one raw query, one dynamic column name, that protection is gone. And I'm going to show you exactly how an attacker walks right through the gap. Hi, everyone. Welcome back to the channel. My name is Victor. And if you are new to this channel, over here, I try to throw light on some of the vulnerable security gaps that developers tend to overlook and then later comes back to bite them by making their applications vulnerable to attacks. I show you how those vulnerabilities are exploited, and then we go further to see how we can remediate all those vulnerabilities to safeguard our application and to safeguard the user data. So if that's your thing, don't forget to hit the subscribe button. It really helps a lot. So today, SQL injection in Laravel lab. I've built a small Laravel lab for this project. And I've done what a rushed or overconfident developer might actually do in the real world. I reached for a raw query to get something working, dropped user inputs right into it, and moved on. Looks fine, passes the test, ships, and that one shortcut is all that an attacker needs. We are going to find that injection point, confirm it, and then work all the way up. From a broken login, a search box, to pulling data straight out of the database that we are not never supposed to see. The reason I'm using Laravel is that it teaches a bigger lesson, not just because I'm also a Laravel developer, but it really teaches a bigger lesson. A secure framework is not the same as a secured application. The framework handles all user defaults, but the second you override them, the responsibility comes right back to you. Quick but serious note, before we dive in, everything here runs in a lab I've built and control, and I am authorized to test it. This is for learning purpose. This is for learning how to defend your application. Don't point these techniques at any application that you do not own or have explicit permission to test. It is illegal to do that. We do this to build safer and secure software. So without much ado, let me share my screen and then let's get into the Laravel lab. So we're going to see if this lab is vulnerable to SQL injection through the URL. And then we also look at how we can use the information that we will get through the SQL injection to brute force our way to log into the application. We also go further to check whether the search form is susceptible to SQL injection. So let's start with injecting the URL to find out if this is vulnerable to SQL injection. To start, I'm going to turn on my proxy. Then intercept the traffic. So I'm going to run this URL. Send it to repeater. Then let me turn it off. So I then save this payload. Now from here, I am going to use SQL map to perform my SQL injection. So what this syntax is doing is I'm using SQL map to read the payload from the file that I've named request.txt, and I've set the level to 4 and the range to 2, so I don't end up breaking the application. And because I know the database is running on MySQL, I put in the MySQL, so SQL map wouldn't spend a lot of time trying to identify what particular database it is before we go ahead to actually do the attack. So SQL map has finished running, and this is what it came out with. So it tried performing SQL injection with various form of SQL injection attacks. So one of them is this payload. It tried this payload, and then it tried this payload too. And then the third payload that it tried was this. And then the fourth payload that it tried was this. And it's all confirmed SQL injection vulnerability. But with that, we're always also able to get juicy information from the run. We were able to find the PHP version that application is running on, the Apache version, and then the backend database management system. But we already knew this, that it's MySQL, so there's not a new information. That you can see all this juicy information that the application is giving out. This helps an attacker to tailor the exploit right to these particular versions. And then it's also specified that there is an error that was thrown, meaning when it tried the SQL injection, it had an error. Also confirming that the application is truly susceptible to SQL injection. So let's manually also try to see the error that it got when it was running the SQL map to confirm for ourselves whether it is true or not. So I'm going to copy one of the payloads. I'm going to try this. Let me add that to the URL here. So this is the error that SQL syntax was complaining about. And again, this gives us some juicy information that every attacker would love to have, because we were able to identify the ports that the application is running on, the name of the database that the application is running on, which is exactly what we need. So with all this information, we're now going to use this information to find out the table that the database has. If it has a users table, and then we try to retrieve the user information from the users table with this information that the application is giving us. So with what this syntax is doing is we again going to run that same request.txt file containing our payload, and then we've specified the name of the database that we targeted. From the error, we're able to identify the name of the database to be labs. So that is what we have over here. And then the users table, the table within the labs database that we are going to target is the users table. So we're going to dump all the user information within this table. And here we go. So without having access to the application database, we've been able to retrieve all the information within the database. We have the admin email address, and then we have the admin password. Then there's another user's email address, and then the password. All this was because of one simple error that the user should have corrected. So before we even go into the remediation, I would like to say, if you ship your application to production, turn off the debug from true to false, so the application do not spit out the actual trace stack. So I'm going to copy the admin email address, and then we will use that to brute force our way into the through the login form to log into the application. So this is what we're going to do. We now have the login, the administrator's email address, but we don't have the password to log in. So what we're going to do is we're going to perform a brute force attack on the login screen in order to get the password, the administrator password, and then you will now come and log in with the password to gain access into the application. So I have a Python script that I've saved in this directory called tools, and that is what I'm going to use to perform the brute force attack. So what this is going to do, so this script is going to use a word list to go through all the presumed password that this application could have, and then we will get the actual password from this brute force attack. And there we go. So the brute force attack came out with the administrator's password being admin123. So let's try see if we will be able to log in with this particular password. Admin123. Let me just copy it. Then let's come to the application, paste it here, and see if we want to log in from here. And there we go. We've been able to access the restricted area of the application without actually knowing the password, all because of one simple error that was committed by leaving the debug on, even though the application was in production. So with this knowledge that we have now, let's now try to see if we can also perform SQL injection on the search form. But before we even do that, let's test first whether the search form works. Okay, so the search form works as it's intended to. We're going to turn on best suit, and then we'll try to intercept the search payload. Let me go ahead and save the payload, then we can use it in our attack. So the attack has started. So as you can see here, it tells shows that get parameter search might be injectable. So right from the get-go, we're getting some information that our search form is injectable. So let's see the payload that will make this possible. It's done running, and again, 3 different payloads were tested, and they all prove the search form was susceptible to SQL injection. So with this knowledge, again, from here, if we didn't know the user's information, we could have performed the same SQL map attack to get the user's information, but it's the same process. So I'm not going to go through it all over again. But this is how you can test your application to check whether it is vulnerable to SQL injection or not. So with this known, I'm now going to show you the code that is running behind this vulnerable lab, and then we will see the patch code, how secure the patch code is. So this is a function that was getting the product information through the URL. So as you can see in this function, the query is a raw SQL query. Anytime you anytime you deviate from using Laravel's Eloquent ORMs and you try to write your own SQL raw query, you are likely to end up with a SQL injection. So this is a vulnerable function that you should never write. You should never write a function like this. And let's go ahead and then look at the patch function, how the patch function looks like. So here is the patch function. As you can see from here, we're not using any raw SQL syntax in here. We're using Laravel's Eloquent find to retrieve the product that we are trying to find the information about using the ID. So this way, there's no way any SQL injection is going to pass, because any input that is coming in is sanitized before passing it to the database. So I'm going to perform similar attack on this patched function. And then from there, we'll be able to determine whether what I'm saying is right or wrong. So this is the patch version. Let's try to perform the same SQL map on this and then see whether it is vulnerable or not. So as you can see, right from the get-go, it says test shows that get parameter ID might not be injectable. So let's finish it and see what it finds out overall. So it's still trying all other forms of SQL injection to break it. So it's now trying to inject the sleep query to see whether it's actually SQL injectable. So it's now trying to perform a union test to further check whether it's indeed susceptible to SQL attack. And then it came back with this information: get parameter ID does not seem to be injectable. You will let it run again to see what it finds out by trying all other variants of the payload. And from the SQL map that we run on the patched version, we realized the ID was not SQL injectable. So which places emphasis on the importance of using Laravel's inbuilt ORM for all your queries and interactions with the database. Never use raw SQL syntaxes in your query. With that said, I will also want to explain how we were able to do the brute force from the login page. So this login page is a very secured login page. This page do not have any vulnerabilities, but we were still able to perform brute force attack, and then we were able to log in, which tells you that brute force attack has nothing to do with how secure your application is. You should always make sure that you're using strong password for all your applications. If you don't, it's easy to use brute force to log into your application. And one way of also avoiding brute force is to make sure you're performing rate limiting on your applications. So continuous ping on your applications can be blocked. Now let's go ahead and then look at the function that is running this search page. So I will show you the vulnerable code, and then I'll go ahead and then also show you the patch code. So this is the function that is running the vulnerable search for. And again, as you can see from here, the search query is using raw SQL syntax. So this is the query that is performing the SQL, which is allowing the injection to occur. And then now let me go ahead and then show you the patch version. So this is the save and the patch version of it. As you can see, we're using the Laravel ORM Eloquent version here. We're performing the where clause on the product. Everything is going through the ORM. No raw SQL syntax over here. All parameters or all inputs that is coming in here is already sanitized and in no way going to affect our application. And there it is, SQL injection in the Laravel app, from a straight raw query all the way to pulling data straight out of the database. The big takeaway is the framework wasn't the problem. Laravel gave us safe tools. We got hurt the moment we reached past them and trusted user input we should never have trusted. So use the query builder and the Eloquent binding by default. Treat every raw input as a red flag that deserves a second look, and never ever concatenate user input straight into a query. If this helped you, do me a favor by hitting the like button. It genuinely helps the channel to reach more developers who need something like this. Drop a comment with what you would like me to break down next, and subscribe so you don't miss it. And before I go, I would like to take a quiet moment, like I always do, and say a prayer for everyone watching. Heavenly Father, thank you for everyone who showed up and learned something today. Thank you for curious minds and for hands that want to build things well and protect what's been entrusted to them. I ask that you guide how they use what they have learned, with honesty, with integrity, always to defend and never to harm. Watch over them and the people they love, and in everything they build, let something good come out to the world. In your name I pray. Amen. Thank you all so much for watching. Take care of yourself, keep building, and I'll see you in the next one. Bye-bye.